Okay, welcome back. And now we're going to talk about the product rule. Now the product rule, you got to be careful. It is not like the other rules, because the other rules we followed a very similar pattern. It does not follow the same pattern. So for example, if I have two functions f and g and I'm multiplying them, the derivative of the product is not the product of the derivatives. So let me say that again. The derivative of a product is not the same as the product of the individual derivatives or the derivatives of the individual functions. Okay? So be careful. So it's different. Okay, so let me show you and then we'll go forward. So Theorem 4 is the product rule. It says let f and g be differentiable functions. If they are differentiable functions, then the derivative of the product of f and g is equal to the derivative of the first function times the second plus the derivative of the second function times the first. So let me say that again. The derivative of a product of two functions is the derivative of the first times the second plus the derivative of the second times the first. Okay? That's how you apply the product rule. Okay? So, now, we're going to do a proof. Okay? So, the proof of this, let me start at the top. So the first thing we're going to do, and I didn't do this, I mean I said it but I didn't write it down, is we're going to assume that we have two differentiable functions. So we start with the assumption f of x and g of x are differentiable. Okay, it's important to have that assumption. Okay, now, at this point we need to use the fact that since g is differentiable, it is also continuous. Remember, I've said that multiple times. Since g is differentiable, it is also continuous. Okay? In particular, we use the fact that since g is continuous, then guess what? We know, okay, so let me write this. Okay, so how do I write this? So assume, okay, since g of x is differentiable, it is continuous. Since g of x is continuous, then we know the limit as h approaches 0 of g of x plus h, right, equals that, right? So we know that's true. Excuse me. Now, by applying the limit definition of the derivative to the product, this is how we're going to do it. So again, this is going to be key here. So now what we're going to do is we're going to take, again, let's define j of x is equal to, f of x times g of x. Okay, now, here we go. J prime of x equals the limit as h approaches 0 of what? We're going to get f of x plus h times g of x plus h minus f of x times g of x over h. Okay, right? So that's what we have so far. Okay, and all we're doing is using the definition of, or the limit definition of a derivative, I should say. Now what we're going to do, excuse me, is we're going to add a form of 0. Okay? And the reason why I'm doing this is because we're going to manipulate the numerator so that we can get something that we can split into a sum, right? Because we know our answer has to have a sum in it. So we've got to somehow get a sum in the numerator, and then we can split it apart. Okay? So what we're going to do is we're going to add the product f of x times g of x plus h, because we don't have a g of x plus h, and but we have an f of x, but not a g of x plus h, right? We want a g of x plus h here. So let's add f of x times g of x plus h minus f of x plus, not plus, f of x times g of x plus h, okay? And so then it becomes that, okay? Now, what I'm going to do is I'm going to rearrange things as follows. So, how do I want to break this up? I want to okay, so what I want is I want to match this one up. Yeah, so I'm going to put this one with this one. That'll do it. So what I want to do is I want to do f of x plus h times g of x plus h minus f of x times g of x plus h plus, now I'm going to add the same thing, plus f of x times g of x plus h minus, minus f of x times g of x. So all I did was move the numerator, the terms around the numerator, and then I get h. Okay, now I'm going to split it right here. So now I get the limit as h. Now the reason why I can do this is because the functions are differentiable, hence continuous. So I'm just using the limit laws again. So this is going to be the limit of this one, f of x plus h times g of x plus h minus f of x times g of x plus h. Now, some of you might see where this is going, right? And then we get plus, now I'm going to have to write a little bit smaller, plus the limit as h approaches 0 of, now the second part is going to be f of x times g of x plus h minus f of x times g of x over h. Okay, now, you can see now we can factor. Okay? So now, let's rearrange some things. Right? So notice that we can factor, actually let me erase, when I go back up to here, give myself some room. Okay, so now what I'm going to do is I'm going to factor out the numerator in both of these. So I'm going to get the limit as h approaches 0. And the first one is going to become the common factor is this one. So I'm going to get g of x plus h times f of x, f of x plus h minus f of x over h plus the limit as h approaches 0. Now the greatest common factor here is f of x. So we're going to get f of x times g of x plus h minus g of x all over h. Okay, so now that's where we're at. Now, I'm going to rewrite this one more step, limit as h approaches 0, and I'm going to say this is the same because, again, this is in the numerator. I can write it off to the side and separate it. So this is going to be g of x plus h times f of x plus h. Now you can probably see where this is going now. You can see it better, right? Plus the limit as h approaches 0 of, now this is going to be f of x times g of x plus h minus g of x over h. Now you guys probably see it. So now, guess what? I can use the fact that I can distribute the product, the limit of the product is the product of the limits. The limit of the product is the product of the limits. Remember the limit laws. So now I can do this. What's the limit of this one? Well, we know, we just discussed that. The limit as h approaches 0 of this is g of x. So I'm going to get g of x. And then what's the limit of this one? Well, it's f of x. This is the difference quotient for f of x. So this is going to be f prime of x. And then we do the same thing over here. The limit of this one is just f of x, right? As h approaches 0, the limit of f of x is what? F of x. And then times, what's this? This is the difference quotient for g of x. So the limit as h approaches 0 of this gives us g prime of x, the derivative. And we're done. We got g times f prime of x, so g of x, right? So we can switch these and we get the first times the derivative of the second plus the second times the derivative of the first. Or, yeah, same thing. The derivative of the first times the second plus the derivative of the second times the first. However you want to say it, but it's the same thing. And that's it. Have a great day.